In this question, we've been told that the proportion of tiles with minor faults produced in a factory is thought to be 10%. The factory manager believes that the proportion is higher due to their old machinery. The old machines aren't producing perfect tiles like they used to. He inspects a random sample of 20 of these tiles. We're asked to find a critical region to test the manager's belief at a 5% level of significance. So it is a hypothesis test, but we're using the critical region technique. So we'll do the usual things we do. The null hypothesis is that the proportion is 10%. The alternate hypothesis, the manager's belief, is that the proportion is greater than 10%. Our distribution, the manager has inspected 20 tiles. Probability that they're faulty is 0.1. So the expectation is 20 times 0.1 or 2. We would expect normally to see 2 faulty tiles. Here's our diagram to help visualize and create the correct probability: 0, 2, and 20. Our significance level, 5%. So to conduct a critical region hypothesis test, we are looking for a critical value, a value that has less than 5% above it. And we're going to find this by using trial and improvement. The probability that x is greater than or equal to 4, we can find that on our calculators: BCD, 4, 20 as our minimum, maximum, 20 and 0.1 as our N and P. Well, that's 13.3%. That's too big to be significant. That's not going to be our critical region. We'll try the next number along. The probability that x is greater than or equal to 5. So BCD, 5, 20, 5 is our minimum, 20 is our maximum. And this time round, we get 4.3%, 0.0432. This is smaller than 5%. This will do. This will be our critical region. X is greater than or equal to 5. In part B of the question, we're asked to state the actual significance level for a test using this critical region. A significance level, we aimed for 5%, but we won't always get that. But we can find what it actually is for our test by finding the probability of our critical region. We've actually already done this. The probability that x is greater than or equal to 5 is 0.0432 or 4.32%. We usually represent significance levels as percentages. So this is the actual significance level. As we move on to question 3, we're told that 4 of these 40 tiles were found in the sample, and we're asked to complete the test. So basically to give our conclusion. Well, the critical region is the region where we would reject H0. 4 is not in the critical region, so we are not going to reject H0. We do not have a significant result. We just need to finish up with those 2 conclusion statements we always write, one of them being mathematical and the second being in context. So mathematically, there is not enough evidence to reject H0, and in context, there is not enough evidence to suggest the manager's claim is correct. Or more specifically, there is not enough evidence to suggest that the number or the proportion of faulty tiles has increased.